I would very much like to welcome, first of all, Professor Barbara Oakley, a world-renowned researcher in neuroscience, and I think it would be definitely a great use of this time to listen what Professor Oakley is going to tell us. We had a brief conversation just beforehand, and I already feel that there's going to be a lot of interesting stuff going around here. So thank you so much. I'd like to thank one of the parents who already helped us to set up this whole meeting. So thank you, Aleksandra Wilczyńska. Hello, everybody. Hello, students, teachers, and parents. On the organizational side, this meeting will be recorded and will be published. So I would very much like to everybody to understand and be notified of that. The structure is as follows. We're going to have around 50 minutes of Professor Oakley's lecture, and there's going to be the time to ask questions which Professor is going to answer. I'd like to ask everybody to mute their phones, if possible. And basically that's it. Streszczając jeszcze raz krótko po polsku, bardzo serdecznie witam wszystkich, witam panią profesor. Zasady organizacyjne, prosimy o wyciszenie mikrofonów. Spotkanie jest nagrywane. Wykład potrwa około 50 minut, potem będzie czas na zadawanie pytań. No i wykład dotyczyć będzie tego, jak działa mózg, jak można jak najbardziej efektywnie się uczyć, wykorzystując tą wiedzę. So, Professor, if you're with us, I think I can give you the floor, and we're listening.
Thank you so much, Lucas. It's really a pleasure to be here. And so let me begin by sharing my screen. So let's see what we've got. And we'll come up here and let's see, we're here and here. And there we go. And we are, okay, so can you see everything? I hope.
Yes, we can see everything.
Okay, good. Let's see here. Let's see if I can get everything. Okay, so I should begin by giving a little bit of information about my own background. And that is that I grew up moving all over the United States. So by the time I was about 15 years old, I had lived in 10 different places. Now, a problem is that when you are growing up, if you, mathematics is a very sequential subject. And if you fall off anywhere along the way, it can be hard to get back on track. So when I was about 7 years old, I was moving from Texas to Massachusetts, and suddenly they were far ahead of me in the multiplication tables. So my little secret is I didn't like math anyway, and so I just gave up and I failed in my studies from elementary through middle and through high school. And that is a little ironic since I am speaking with you here today as a professor of engineering. And one day, one of my engineering students, he found out about my terrible past as a math flunking student. And he asked me, how did you do it? How did you change your brain? And I thought about it. I mean, I was a little kid who I loved animals and I liked knitting and weaving, and I knew I could never grow up and do anything technical because I couldn't do math. And so what I decided to do was to learn a new language. So I found out there was one way to learn a new language and actually get paid for it, and that was to join the army. So there you see me looking very nervous, about to throw a hand grenade. If you knew how clumsy I am, you would know why I look so nervous. But I did learn another language. I learned Russian. I should obviously have learned Polish because many of my best teachers in engineering studies were from Poland. So, but I ended up working out on Soviet trawlers up in the Bering Sea. And I just loved having new adventures and seeing the world through new perspectives. So I also ended up at the South Pole Station in Antarctica. And that is where I met my husband. So I always like to say I had to go to the end of the earth to meet that man. But the thing is, when I was getting out of the military, I was 26 years old, and all my friends had good background training in engineering, but I did not. So I thought, now, wait a minute. If I am supposed to be open to new adventures and new perspectives, why don't I see if maybe I can try a new adventure of the mind and begin learning in math and science? So at age 26, I went to the university. I began at the lowest possible level of mathematics, which is remedial high school algebra. And slowly I began climbing my way up. And obviously it was successful, but it was not easy. However, if I had known then what I know now about how the brain learns effectively, I could have made it so much easier on myself. So what I want to do with you this afternoon is I want to share with you insights from neuroscience, from cognitive psychology, about how your brain learns most effectively, so that when you are sitting down to study, you're not just kind of doing less effective approaches, but instead you're using the approaches that make most effective use of your time, so that you can have more time to go out with friends and enjoy yourself. So if we are looking at how the brain learns, a fundamental building block is that tiny biological cell called a neuron. So neurons, well, I know what you're thinking. This is where I'm going to get to the part of my talk that's really boring because it's scientific. So let's spice it up a little bit with a metaphor. And our metaphor for a neuron and understanding how that biological cell works is a space alien. So our space alien has legs, right? So you can see the legs here. Those are analogous to what are called dendrites on a real neuron. There's 3 dendrites, but actual real life neurons can have hundreds of different dendrites. So those dendrites have little toes on them. Those are called dendritic spines. And these dendritic spines, as you will learn, are really important for learning because they're what allow you to make connections. And lastly, we have an arm that reaches out from our space alien. That's called an axon. So what these neurons or space aliens are doing is they like to reach out with their arms and tickle the toe of a nearby neuron. And what this does is this allows neurons to make sort of connections between one another. So they're mostly electrical connections, and they jump this little gap between the neurons called the synapse. But as we are learning something, as we're learning anything, we're simply making connections between neurons in long-term memory in the brain. So whether you're learning how to do math, or how to speak in a foreign language, or how to do a dance step, or play a musical instrument, whatever you are learning, you are simply making connections between neurons in long-term memory. Unfortunately, psychologists for the last 40, 50 years have said things like, you don't need to memorize things, you can always look it up. Actually, that's not true at all. Would I be able to speak Polish if I just used Google Translate? No, of course not, because I wouldn't have that information within my own brain. And actually, if you don't have those key insights within your brain, you really cannot become an expert at anything. So how do you build those connections within your brain? That is the topic that we'll be speaking of. We know that if you practice with whatever you're learning, you can help strengthen those connections, which is why you practice with English, for example, or Spanish, whatever language you're learning. Or it's why you might do many problems in mathematics, because you're practicing with these connections. And as you practice and strengthen those connections, what you're doing is you're helping build nice, strong connections that make it easy for you to pull ideas in mind when you want to be thinking about things. So, or solving a problem, or speaking in a foreign language, or whatever you have learned you want to be able to do. So this brings me to a question. What do you believe is the most powerful way to help you learn more efficiently? Is it rereading? I did a lot of rereading when I was studying engineering. I would read a page, read it again, and I thought, oh, I'm just kind of getting those ideas deeply ingrained in my mind. Is it highlighting or underlining? Using a pencil to write on the page maybe, or underline with your computer? Or is it something called retrieval practice or recall? That means using something like a flashcard to, you have an idea, you want to check and see if you know the key aspects of that idea, whether it's a word in a foreign language or a concept or an anatomical term, right? You're just looking at your flashcard and seeing if you can remember the key thing you're trying to learn. That's recall. Or is it creating a concept map? So that means writing things down and making connections between them. So of those four things, which ones do you do and which one do you think is the most important? Because research has shown, they studied these four techniques and they found that one technique is way better than all the others. And that technique is retrieval practice. So that means pulling the idea from your own mind, having it on a flashcard, seeing if you can remember it without looking at the back. You're just looking at the back to check whether you remembered it. Retrieval practice is valuable because when you first learn something, you create these weak sets of links in long-term memory. But each time you pull those sets of links from your memory, you strengthen them. When you're rereading a page, for example, you are not strengthening those links. You're just kind of looking at them and passively letting your eyes go over them. When you're first reading a page, you are doing something like this. You're doing initial learning. So you're getting those initial links laid down. But it is only when you look away from the page and ask yourself, what were the key ideas? You retrieve them from your own mind. That's when you build and strengthen whatever you're learning. So if you don't retrieve, so let's say that you are studying and you're learning something in class, but then you're very busy for a couple of weeks. And so you don't have time to review the material any further. What happens? Your little synaptic janitors sweep those connections away because you're not using those connections. So this is why it can be very important. Don't just learn something and put it away. get it and retrieve it in mind over a number of days. And what's actually happening is when you learn it, you first learn it, you're learning something, and when you go to sleep at night, that's when you really strengthen those connections. So here's what I mean. This is a real living neuron, part of a neuron. You're a neuroscientist now, a young one. So you can see that this is actually a dendrite, that leg of the neuron. And these are dendritic spines. So this is a real living neuron before learning and before sleep. And we're going to see what happens to this dendrite after learning and after sleep. Can you imagine what it will look like? Do you think it might have a fatter leg? Or do you think there might be more neural spines, dendritic spines? Let's see. If you look at the same living neuron after learning and after sleep, look at what we see. Before, that dendrite or the dendritic spine did not have strong connection. But after learning and after sleep, notice how much bigger the end of that dendritic spine is. It has strengthened because of learning and because of sleep. And here you see a dendritic spine that wasn't even there before learning and before sleep. So sleep itself is a very important time for learning. It's when the brain, because it's resting, it can really build and practice with those connections that you have been starting during the day. And what this means is that when you are learning things, you want to practice over a number of days. So if you're studying something, let's say you have 5 hours to study a subject during a given week. You don't want to do this kind of thing where you cram 5 hours in one day. That makes it with very weak connections that are very easy to sweep away. Instead, you want to space out your learning. So it's called spaced repetition. That means 1 hour, for example, on Monday, another hour the next day. And by spacing out 1 hour each day, you learn it, and then you're strengthening those connections during sleep. Learn it, strengthen again during sleep, and again during sleep. So you can see by the end, you have much, much stronger connections than if you had tried to just cram everything in one day. So again, spaced repetition in learning is very important. I'm giving an example of 1 hour per day over 5 days, but that's not a hard and fast rule. In other words, let's say you have a half an hour a day over several days that you can devote to one topic. Or perhaps you might have 3 hours per day that you can do for a topic. It's really valuable to just space that learning out over a number of days, and you will learn better. I should say that it is much better to practice by using short bursts of time. So not 3 hours, rather 25 minutes, a little break, 25 minutes, a little break. And we'll talk more about that in a little while. So learning is kind of like building a brick wall. You lay a layer of bricks and mortar, bricks and mortar, and you take your time so that the mortar dries between the layers of bricks. If you don't take your time in learning, you have a very poor foundation for learning. So it's important to take your time as you're learning things. Now, you can kind of think of it like this wrestler here. He is he didn't sit there the night before this big meet and say, oh, I'm going to cram and I'm going to build this muscular structure. He took a long time to build that muscular structure. We don't realize it, but actually, because we can't see into the brain like we can see muscular structure, but it is very similar. Neural tissue is excitable tissue, much like muscular tissue, and it takes time to develop. So learning, that's why it's a poor idea to cram. Now, one way that I can help, kind of give you an example for how to learn effectively is, for example, here's a flashcard system. It's one of my favorites called I Do Recall. And with this flashcard system, you can build your own. For example, I upload my own PDFs or books, whatever I am learning from. I can upload it and I can easily copy and paste and create the flashcards that I want to create. You can see I can have a little pin and I can create my flashcard. And it's a really easy system to use to create flashcards. You can also use electronic books and even videos on YouTube. You can easily create flashcards from whatever they have. If you are a teacher, you can use I Do Recall to create groups. So this is my favorite flashcard system, but there are plenty of flashcard systems out there. And so I highly recommend any kind of flashcard system. Other good systems include things like Anki, Quizlet is another one, Kahoot. These are all good flashcard systems that can help you with recall. And one thing I should say is that people sometimes make the mistake of thinking that retrieval practice or recall is only for simple things like vocabulary words or anatomical terms or things like that. Nothing could be further from the truth. Retrieval practice, as we now know, means retrieving and connecting key ideas in your own mind, and it is a powerful way to conceptualize and think much more deeply about problems. It depends on what you're retrieving. If you ask yourself using flashcards very simple retrieval questions like, what is this word in English? You'll not, I mean, that's very helpful. You need to know these terms. But you can also ask yourself much deeper questions. You can ask yourself, why in a identity matrix in mathematics do you have certain terms on the diagonals? If you ask yourself very deep and penetrating questions on retrieval, you can learn a lot. So retrieval practice is probably one of the great keys to good learning. But I should switch gears a little bit, and I just want to talk about some of the brain's very dramatically different ways of thinking. It turns out that there are two fundamentally different modes that the brain uses to think. One is called focused mode. That's hopefully what you're doing right now. You're focusing on me. And this uses a certain set of networks in the brain. There's a different set of networks that I'll call the diffuse mode. Neuroscientists call this the default mode network. Psychologists call it the task negative network, while this is the task positive network. For a long time, people thought that the diffuse mode or default mode network was when we weren't really thinking about anything in particular. And that's kind of true, but it's also a mode of thinking that we use when we're making dramatic connections between things, when we're thinking creatively about things. So these two different modes are really important in the learning process. And I should go a little deeper to help you just get a sense of why these two different modes are so important. So to go deeper, we'll use a metaphor. And the metaphor we're going to use is that of a pinball machine. Now, this pinball machine is very old-fashioned. It was a game used like in the 1950s and 60s. You just pulled back on a plunger and a ball would come bouncing out, and that's how you would get points. This is the basis for many modern computer games. But what we're going to do is we're going to take this pinball machine and we're going to put it right on the human brain. So are you ready for it? Here we go. There is the pinball machine on the brain. And this is an analogy for the focus mode of thinking, like that tight thinking when you're focusing on a problem. So let's say I asked you to multiply 72 times 28. Your brain would, the thoughts would move right along pathways of learning that you had already laid because you already learned multiplication. So that's if you've already learned multiplication. In fact, as you have learned anything, your expertise in addition, multiplication, speaking a language, playing a musical instrument, you've just laid pathways that you can easily follow when you want to play a song or work a problem. But what happens if you're learning something completely new? So you haven't laid those pathways before. Let's say that you know multiplication, but you haven't learned division. So you might be trying to lay these pathways of division, but you can find that your thoughts can slither back up to the previous multiplication thoughts. And what this means is when you get these first difficult problems in multiplication, in division, you can't solve them. And in fact, you're sitting there, you're trying to do your first really tough division problem, and you just can't get the answer. And you look at the book, it doesn't make sense. You're trying, and you get very frustrated. You close the book, you walk away with whatever this new thing you're learning that you're very frustrated by. Maybe you're trying to say a phrase in a foreign language and your mouth just won't do it. Or maybe you're trying to learn a new concept related to how the heart works. But whatever it is you're trying to learn, you start to get frustrated, you close the book, you walk away, and when your focus gets off of that concept that you're struggling with, that you can't really grasp, it opens up that new network of thinking in the diffuse mode. So you get your mind off of what you're focusing on, your mind broadens into this other network with broad connections. And you cannot think in the careful, focused way you could when you were in the focus mode, but you can at least get to the new pathways that you need to be able to solve that problem or understand that new concept. So as you're learning, your brain goes back and forth between focused and diffuse modes. You can't be in both modes at the same time, unless you're perhaps having ADHD, for example, attention deficit disorder. When you try to focus, it can automatically bring up that default mode network. And that can make it difficult to really focus because your mind can skitter off, can go off into other directions. But if I had known when I was a young person that it's okay if I'm trying to learn math, like the multiplication tables, and I can't understand a concept, it's okay to work at it for a while, try to get things loaded into the focus mode, but then step away and let the magic of the diffuse mode work in the background. Go back and forth. And when you get very frustrated, give yourself that time to step back and let your brain work in the background. So if I had known this, I could have made things so much better for myself. I had thought, oh, I can't do math, but it wasn't that at all. I could easily do math. It's just that I needed more time. Here's an important point. If I learn math more slowly, I can learn it more deeply than the very swift learner who just gets it all right away. In fact, there are some Nobel Prize winners who won the Nobel Prize because they were not very good learners. They were very slow. But when they were learning something and they were trying to understand it, would find errors that the very fast learners just jumped right over. But those Nobel Prize winners would say, but there's a problem here. And by burrowing into that problem, that's how they won the Nobel Prize. But what's important for us to know is that if we have to go back and forth between those two different modes, we need to make sure that we are not procrastinating. What is procrastination? It means putting something off that you should be doing, like studying. It can be very easy to say, I'm going to study today. I'll do it this weekend. But as you can see, if you do a little bit every day instead of cramming on the weekend, you can do much, much better in your studies. But why do we procrastinate? As it turns out, when you even just think about something that is, that you don't want to do, it activates a portion of the brain that can experience pain. The brain, naturally enough, kind of skitters away from that thing that made you feel unhappy to the thing that makes you feel happier. And the result, you feel happier when you turn your attention to something more pleasant. But of course, you have just put things off. You've just procrastinated. So let's just jump to the most powerful tool to help you prevent procrastination or tackle it. And that is the Pomodoro technique. This was invented by an Italian, Francesco Cirillo, in the 1980s. It's a wonderful technique because it's so simple and it's so elegant. So like when you get home from school and you say, I'm just going to go do something else for a little while, it can be really good to just instead say, I'm going to do one Pomodoro and then I'm going to go take a break. So a Pomodoro means first turning off all distractions. So you just sit down, you get rid of all distractions. So maybe you're in your bedroom or in the library, and you make sure that there's nothing popping up on your cell phone because that's going to distract you, nothing popping up on your computer because that will distract you. And then you set a timer for 25 minutes. You focus as intently as you can for those 25 minutes. So let's say you say, I'm going to work on my homework for 25 minutes. And then 5 minutes in, you go, oh, wait a minute, I was going to call Sally. Well, guess what? You just make a little note to yourself, but you return your focus to whatever you're working on. So those 25 minutes are devoted to keeping your attention as best as you can on whatever you're trying to do. That's all you need to do is just work as intently as you can. But when you're done, give yourself a little reward. And by like a 5-minute reward. So maybe something like you get up and walk around, or you listen to your favorites, or have a cup of chamomile tea, mint tea, whatever you can that will allow your brain to relax and to grab and work with those ideas. It's called consolidation. So those 5 minutes are really important to allow your brain to rest and not get new incoming information. So by that, I mean, don't say, oh, it's my reward period. I'm going to get my cell phone and look at that. No, because when you focus on your cell phone and then you go, oh, Ola called me. I have to respond with a text. You are going right back into focus mode, and you are overwriting the learning that you just did during those 25 minutes. So really, truly allowing your brain to rest or relax, like, a little music is okay. A light physical task is okay, like sweeping the floor or walking around a bit, but not focusing for 5 minutes will allow that new information you've learned to really get into your long-term memory better. So many people like to use, like they'll do 3 Pomodoros followed by a 4th. So 3 of them, and each of these 3 has a 5-minute break. And after the 4th, they'll have maybe a half an hour break. So if you have something like 2.5 hours to study, a good way to study is with these little built-in breaks. And what they find is those little breaks allow that diffuse mode to go to work. If you focus intently for the entire 2 hours, you will not get as much learning because you're not making good use of both focused and diffuse modes as you are beginning to learn. So one thing I want to re-emphasize is this point that if you are a slower learner, you can actually do just as well, if not better, than the fast learner. A slow learner like me, they forget. So like I'll memorize, I'm trying to learn Spanish now. I'll memorize a vocabulary list and then, I'll check the next day and I've forgotten things. Those dendritic spines have melted away. A faster learner, on the other hand, they can remember everything. Oh, wouldn't I love to be like that? Not necessarily. Because as it turns out, because I'm a slower learner and I have to go back and revisit the vocabulary list the next day, I learn again and again. I have to practice again and again, but I am much more flexible in what I'm learning. So a fast learner, they learn very quickly, they lock those spines into place, and they can't change them very easily. So sometimes you will meet very, very smart people who can remember things, but they can also be very, very inflexible. They can't change their minds. Once they think they've got the answer, they can't change their minds. So if you're a slower learner like me, just keep in mind that can actually be an advantage, even though you may have to work harder to grasp the material. So as you're learning, just kind of think of it. Some people are like race car learners. Some of them are like hiker learners. Race car learners, they're very fast, but everything goes by in a blur. Hiker learners, they can get to the finish line much more slowly, but they can reach out, they can touch the leaves on the trees, they can smell the pine in the air, hear the birds. It's a very different experience, and in some ways, much richer and deeper. So let's move on to another. I just want to cover a few more quick ideas that can help you with your learning. An important idea relates to the difference between what's called working memory and long-term memory versus octopuses in the brain. So if you think about it, Working memory is in the prefrontal cortex. I like to think of it as being like an octopus that has only 4 arms. So octo means like 8. So this is 4 arms. So it's like a quadrupus. So here we go. You can see this little working memory is waving its 4 arms. And working memory is a temporary place we put information. Whereas long-term memory is more towards the back of the brain, and it is where we place those links of long-term memory that we create through practice. So as we are learning something, our working memory is creating these sets of links, and then we practice and put them into long-term memory, where our working memory can later pull them out whenever we need that information. Now, what we do, well, this actually brings me to our younger daughter, Rachel. So I asked Rachel to model what it felt like for her when she was learning to back up a car. So Rachel had learned to back up a car not long before. So she was like, Mom, I'm happy to demonstrate what it felt like when I was learning to back up a car. So what I want you to do is watch Rachel's little face as she's learning to back up a car. So she's looking in the side mirrors, she's looking in the front, in the back. And then of course she's learning, but she's not very effective. So off she goes into the ditch. Learning, it involves working memory, and it can be hard. You can only hold about a maximum of 4 pieces of information in mind at once. It's called a heavy cognitive load. So that means all the arms of your working memory are busy as you're first learning something difficult. You don't have arms on your attentional octopus or anything else. But once you learn how to do something like back up a car or to do the multiplication tables or something, all you have to do is think, back up a car, whatever. You pull those links to mind and you have a light cognitive load. It means you have arms available for other ideas, for more complex thinking. In this case, it would be like, okay, I'm backing up a car, but what's that song playing on the radio? Is my seatbelt fastened? You can think about other things. Now, what happens is when we are sitting down, for example, to take a test. So you're sitting down, going to take a test, and what can happen is your working memory will come up. It'll say, oh yeah, I learned this aspect and that aspect. I can connect things together and I can actually do well on this test. In fact, I should say that doing tests, doing sample tests, example tests, is a form of retrieval practice. And these example quizzes and tests can be powerfully effective. In fact, they're one of the most powerful tools to really ensure good learning. Sometimes people will be taking tests and they will sit down to do the test. And that's when they found out that all the information is only in working memory, not in long-term memory. And that can happen because you are not practicing during your studies by using retrieval practice. So if you're just reading, you think you've got it in mind, but you have it only in your working memory, not in long-term memory. It's only when you do retrieval practice, do a lot of practice tests, which enable this retrieval practice, that you ensure you've really got that information in long-term memory. So I do want to just touch on something interesting from movie making. The neuroscience of movie making has helped us to better understand working memory. So if we look at working memory, our thoughts that we're pulling into working memory that's called a mental model, is these temporary thoughts that are being held with our working memory. So as you are learning something, you're basically kind of trying to get together the main thoughts of whatever you are trying to really learn and understand. These mental models, those thoughts, are what help shape our long-term memory, which is often called a schema. So your long-term memory related to those ideas is shaped by those thoughts that you're pulling together as you're learning. Let's look a little more carefully at what a schema is. We have these neurons here, but it can be really hard to always use neurons as we're drawing. Sometimes it's easier to just call them dots and then connect those dots or those neurons with lines. Stronger connections have thicker lines, and all of these connections help form our schema of expertise in whatever we're learning. So this represents neurons and their connections. So as we're learning something, we're actually developing and building a set of neural connections, and that is the schema. Now, as we're developing these schemas, what we're doing is we're sort of like, let's say we're learning Japanese. We've got a schema that we're developing, chemistry, biology, but this person doesn't know a lot about history, maybe knows much more about geography, a little bit about geology. So as you're learning subjects in school, you are developing schemas about those topics that you're developing your expertise about. And as you're learning, I mean, it's not just subjects in school that help you develop schemas. It's like cultural things as well. You know, how do you open doors in the place you're at? How do you greet people? If you're in Spain, you greet people and hug and kiss both cheeks. If you're in Thailand, you may greet by doing this. You're learning these things. It's forming a part of your cultural schema. You have schemas about all sorts of different things. You can combine schemas. So like your knowledge of both physics and math can help you with both subjects. They work together. And ultimately, all of your schemas can combine together. You can think of it as that helps you form your identity, your way of thinking about yourself. So for me, for example, what I was doing when I was kind of learning and thinking about myself, let's see, I have a little problem here. What is going on? I have to, I think I had a little crash. So let's see. So now and while I am recovering from this crash, just remember that I think you can post questions and so forth. Be posing your own questions in your own mind so that when we wrap up here, we can have some, hopefully I can answer some questions. So let's see what we've got. Let's see here. Move it up here. No. And we'll go over here. No, here. They make this a little bit tough to, okay, so we'll go back down here to where we were. And there we go. So, okay, hopefully can you, I'm just gonna stop share and I'm gonna go back to sharing just to make sure that we are still on the same wavelength. So, so as you can see, here's my identity schema. And with my identity schema, you can see I had this kind of a dark patch. I thought I couldn't do anything technical, but I actually discovered that I could do something technical. And I'll give you an example of a friend of mine who did something similar. She changed her own brain. So we know that schemas, we'd like to be able to go in as teachers to our students' schemas and change things so they don't have those dark patches and they think they can do everything. We can do a little of that through our emotions and the neural resonance that can occur between people. But actually people can change their own neural schemas. And I'll give you an example of my friend Audrey. And Audrey had her thoughts about what she could do technically were very, very gray and dull. She thought she couldn't do anything technical because she had dyslexia. But then she learned that she could, for example, do like transfer the files from her phone to her computer, simple thing. And that one simple thing made a little brighter patch on her neural schema that gave her a little bit more of a positive attitude about what she could learn. One little thing, and then another little thing, and then another, and she is now not only a popular public speaker, she has grown, and she is now the producer of her own television show on public television network in the United States. She is the technical producer. So she's gone from terrible at anything technological to being very, very good at it. Although, of course, she says, oh, I'm not that good. But she can do anything she wants just by having worked and worked with the material and practiced. She changed that mindset and she changed her schema by learning bit by bit, just as I did when I was learning in math and science and changed my brain. So when you're a student and you're learning something, you've got these thoughts, you're trying to get these thoughts and put them together and put them into long-term memory and then to retrieve them so that you'll help strengthen them. And this is a big part of the learning process. So as you're learning, you're getting input not only from outside, but also from your own neural schema. And this helps you to form mental models. These mental models that you're learning are actually, they're just critical as you are a student. But what I think is important is you can also learn from your friends. So, for example, look at this person. They're all trying to form a mental model. This person pulls some ideas from their neural schema. They share the idea and everybody gets on the same mental model, the one the teacher is trying to share. Now, maybe this person sort of mind wanders and their brain falls out, their thoughts fall away, but the others can help them get back on board. As it turns out, being in neural synchrony with the class and with your teacher is actually a signal that you have learned the material really well. A good thing to do if you're, as you're learning, is to try to break information up into smaller pieces so your working memory can get them. And this breaking up of information is invaluable for learning. So especially notice it's like smaller pieces can fit more easily into the arms of working memory. And then you can more easily put it into long-term memory. So when I look at something big and I can't understand it, I try to understand a little bit and then another little bit and work in that fashion. Because ultimately what you're trying to do, again, is make those connections between neurons, put them into your schema, and then you can withdraw them when you need them, and they're linked together naturally, and you build those links, remember, by retrieving and retrieving and retrieving. So retrieval practice is incredibly important. As I'm closing, I just would like to say, refer to my favorite scientist of all time, who is Santiago Ramon y Cajal. Cajal was a terrible, terrible student. He flunked out of elementary school. And but at age 20, he decided he was going to try to become a doctor. He studied hard. He took a big test, flunked it. Took the test again the next year, flunked it. Took it the third and last year he could take the test, and he became a professor of anatomy. That's incredible for a guy who's a terrible learner. Then, because of how he learned slowly, carefully, he won the Nobel Prize. That's not all. He is actually now known as the father of modern neuroscience. And so he was asked, well, how did a guy like you actually become successful? And he said, well, I was persistent. I practiced. He created those sets of neural links. But he said, also, I was flexible. So remember, because he was slower, he could be more flexible. There are some flexible, very fast thinkers, I should say. But he said, I was no genius, and he was not. And he said, I have worked with many geniuses, and the problem with geniuses is that they can jump to conclusions, and when they're wrong, they cannot change their mind. So if you, like Ramon y Cajal, no genius, rejoice, because you can sometimes do things even geniuses cannot. So thank you so very much for everything, and I'm ready for questions.
Okay, so if anybody's got questions, it would be probably best to write them in the chat so we can answer them. And I can already see there is one question by Renata. You discussed the ideas of focus and diffuse modes. How do being online all the time, scrolling through social media, checking notifications affect the aspect of how our brain works?
So remember that the brain is very flexible and plastic. By plastic, I mean it can change. So sure, if you are checking notifications all the time, what that can do is that can encourage networks of your salience and executive mode networks or to concentrate on the distraction. And sometimes that can be valuable. Actually, like if you're stuck on something, being distracted can actually encourage creativity. But of course, you want to also have times of dedicated focus. And if you build in those study sessions where you make use of the Pomodoro technique, you can actually encourage focusing over longer periods of time, ensure that those neural connections are nicely and strongly built. And, it's not to say you should never do any jumping around on the net and so forth, because that can actually encourage creativity and also build kind of wild connections that can help you be more creative. Just sort of mix things up, have those periods of focused attention and build that into your practice, without saying, oh, I should never do any distracted kind of things on the net. That can be a little fun and also a little bit helpful for creativity.
Okay, so waiting for other questions, and in the meantime, I'd like to follow up on what you just said about this topic of multitasking, because there's a lot of huge discussion on whether there is something such as multitasking, and if it's something we can effectively do, because research is supposedly sociological research showing that the younger generations are intently more multitasking than the previous generations. So is there actually, from the neurobiological perspective, something such as multitasking? And if so, how can we use it effectively? And if not, what to do not to multitask?
Okay, so that's a great question, and I have some really good illustrations that I will work to pull up here. But I should say, so it takes some of my presentations are so large that it just takes forever for them to pull up. But there are about 2% of the population are what are called supertaskers. These are people with differing dopamine genetics that allow them to multitask much more easily. So they can be people like a race car driver or a super good professional chef who can go between things, or a emergency room doctor who can think quickly and shift gears quickly. There are also people with very high working memory capacity. So they have not only 4 arms, but maybe like 10 arms on their working memory octopus. And they actually can multitask effectively because they can put some of their arms on one topic, some on another. So they can be listening to a conversation while they're studying and still do it effectively. The probability is that you are not like that. It's only a very small percentage of people who can multitask effectively. And so, so if you try to train your brain to be a multitasker, it's not going to work very well unless you have the natural genetics to be able to do that. In fact, what can happen is that, let's see, I'm going to share my screen again so you can see. Let's get back up here. I'm going to share screen. And we're here. Okay, so should go here and here. So multitasking actually has 2 different aspects. One is where you're switching tasks. So let's say you're trying to read and then you get distracted, so you go to your cell phone. That's one aspect of multitasking. Another is called dual tasking. So like you're reading, but you're also listening to music while you're reading. So you're diffusely aware of both things. So you should just be aware there's 2 different aspects of multitasking. For most people, again, with the exception of those 2% of people who are super taskers, you will lose a great deal of efficiency by multitasking. It's just not very effective. So we think, well, then that should mean I should never multitask, right? But actually, that's not true, because sometimes switching between tasks can help us to be more creative when we become stuck. There's good research to that effect. So I think just be aware you may ask, well, should I listen to music when I'm studying? Is that, it's being more diffusely aware. It depends on your working memory capacity. If you have a big working memory, you can probably listen to music just fine while you're working, although recommendations are to avoid listening to music while you're doing math, because it uses both sides of the brain. Listening to music can use some of the same parts of the brain that learn math. But on the other hand, one of the most brilliant mathematicians of the 20th century, he loved to listen to music when he was doing his mathematics. So there's no real hard and fast rule about that. But just don't think that you can train your brain to become a multitasker just because if you're not naturally that way, it's probably going to just make you less effective. You're going to lose that 30%. Using the Pomodoro technique is really helpful.
Okay, great. Thank you so much. So we've got another question. It's a question about the value of sleeping. In the age the kids are here, mostly 15 plus and around the age, what is the minimum they need for the relaxing development? And I would follow up, what's the impact of sleeping less than the required minimum, especially for learning?
Okay, great question. Again, it is not well studied, but there are some studies, like researchers on sleep will often recommend, teenagers should have 9 hours, 8 hours of sleep. But there's several caveats to that. One is that some people, again, it's about 2 to 3% of the population, are what they have what is called the short sleep gene. So these individuals can sleep 4 hours in a night and they can be perfectly effective. They're very, I wish I had short sleep genes. But if you don't have those genes, you may have a good friend who's got this gene, and you're like, if I just try, I can be just like them. Well, you can't, because you can't change your genetics. So just be aware, some people can go with much less sleep. It's in Singapore, a typical student has around 6.5 hours of sleep, and which is thought by experts to be a little short, but Singapore students obviously do seem to be effective. One thing they did, which I think is quite interesting, is they did a study on these poor Singapore students, and what they divided them into 2 groups. One slept the usual 6.5 hours. The second group slept 5 hours, were woken up, but they were allowed to sleep for 1.5 hours during the afternoon or during the midday. And what they found was that the group, even though they were only given 5 hours of sleep during the night, if they were given a nap time of 1.5 hours, they outperformed the straight 6.5 hour group. So there's pretty good evidence that taking short naps can be really a helpful thing to do. There's some evidence that starting high schools later can be beneficial because teenagers have their circadian rhythms set a little later. But it can be hard to do just because if you're trying to meld everything in with, parents and their schedules and so forth, that can be very difficult. So a very good question. Mm-hmm. Okay, what is the impact of stress on learning? Okay, so, that's a really good question. It depends on the kind of stress. Moderate stress, for example, stress like taking a test that's coming up, that actually can be helpful. It moves you up a little bit, gets those cortisol levels kind of increased, and you can remember better with a little bit of stress. However, too much stress, for example, if you're in a situation like some students in Eastern Europe are experiencing, where you may really, really be stressed out, in a war situation or something of this nature. What that does is that makes cortisol levels, it really builds them up in the brain. It does some other things too. And those can actually switch that excessive cortisol over long periods of time and in excessive levels can switch off higher cognitive circuitry development. This can make it more difficult for these students to to focus intently on things. And it can also increase the propensity for things like ADHD and dyslexia. So a little stress is helpful, and, like minimizing testing and so forth, because it's thought to be too stressful, that actually can be counterproductive. But too much stress, and that can make substantive long-term detrimental changes in students' abilities to focus intently, although they can be alert to, as a consequence, to things that, potential dangerous things that could happen around them. There's fantastic new studies related, growing from evolutionary psychology, that help us understand these things better.
Okay, so I think those are all the questions, and we're just around time when we plan to finish. So I think we'll be wrapping up.
One last thing, just on diet and learning,
Okay.
very quickly. Both diet and exercise are powerfully helpful for learning. Exercise helps bring brain-derived neurotrophic factor up in the brain, which is like a fertilizer. Incidentally, stress reduces brain-derived neurotrophic factor. If you eat things like eat your onions, cabbage family, eat nuts and so forth, these can combine synergistically with good exercise programs to help fertilize those dendritic spines, so that it makes it easier for you to learn.
Okay, thank you. Thank you so much also for this remark. So I've got more people thanking on the chat. So also I'd like to thank you so much. It was definitely a pleasure and an honor to have you here today. Thank you from our side. Thank you from Poland. And if anybody else would like to ask anything, there's the last moment. If not, we'll be wrapping up.
I would just like to say it's really an honor and a privilege to be sharing with a school that it was such a visionary leader, and really open and incorporating these new ideas. It is just going to be super helpful for you, for your students, and for Poland. So I can't tell you how much I respect, admire, and support everything you're doing.
Thank you so much.